Good morning, good afternoon, good evening. This is Mrs. Wormley, and I am at a conference still, and I wanted you, or I might be back in your class. I wanted to give you these notes on sector area and arc length. I think this is the last thing you're going to learn in Math 2 with me this year. And so we have these circles. On Tuesday, Wednesday, you did the circle definition page and practice circumference and area. And so now we're going to go talk about sector area and arc length. So sector area is just like, here's your sector, it's what's the area of this part of your circle. And arc length is, this is your arc, part of your circumference, and what is that length. So let's review a couple of vocabulary real quick. So the sector, remember, is like your pizza pie piece or your piece of pizza from the center to the circumference and part of the circumference. That's your sector. And so we're talking about what is that. So this is your sector right here. So that's your sector. And when I say arc length, I'm talking about what is this right here. So what's this distance from here to here? That's what I want to know when I ask about arc length. Just remember, this is my arc right here. So my sector is a piece of pie, and this is like, you can think of this like the crust or something. I put crust. I meant arc. That's funny. So this is my arc, which is part of the circumference. And so the other things we have in here we'll have to use at some point. All the way across this circle, do you remember what it's called? The segment, it's not the line. The line we call it a secant, but this part, this is your, did you guess it? Diameter. And then this part right here, this is from the center to the circumference. This right here is it's half of your diameter. It's your radius. Did you guess that? And then if I go all the way around my circle, all the way around, that is called the what? That is called your circumference. All right, so there's some vocab review. So remember from the last notes and practice yesterday or last day you're in here, the circumference, you have two formulas. Circumference is pi times diameter if they give you the diameter, or circumference is 2 times pi times the radius. Whatever one you remember, whatever one you have to use. And then the area of a circle, area equals pi r squared. So when we're doing the sector area, we're doing area. So we're going to be using this formula and then add a little bit. And we're doing the arc length as part of the circumference. We're going to use this formula and then add on a little bit. So remember we talked about this with pi day, the relationship between pi, diameter, and the circumference. Pi equals your circumference divided by diameter. And we did this on pi day. That was really cool, actually. You guys did some good jobs on there. And that's about, when you calculate it, 3.14. All right. So now we're going to practice just a little bit with finding area and the circumference of the following circles in terms of pi. So remember, pi means that you don't need to write out 3.14 multiply. You just put times pi instead. So we're going to do the circumference. Remember, your formulas are right there next to you. This is right here, they gave me what's that? That's your radius, and it's 9. And so I'm going to use my radius formula for circumference. So circumference is 2 pi r, that's my radius. So it's 2 times pi, and my radius is 9. And so I can multiply 2 times 9 to get 18 times pi. That's it. So we can say circumference equals 18 pi. And because I'm not going to estimate pi, I'm going to say it's equal to, not about equal to. If I multiply by 3.14, it would be about 56 and 52 hundredths of a centimeters. but it just wants it in terms of pi. So this is really what they're asking you for. All right. And the area formula, remember, is area equals pi r squared. So they gave me my radius, so that makes my life a lot easier. So my radius is 9, so I say area equals pi times 9 squared, multiply 9 squared, area equals 81 pi. So notice I switched the order here because we usually put the number first and then we'll say pi. So my area is, let me put this below, 81 pi. And if you multiply that out, it would be about 254, excuse me, and 34 hundredths. So that would be like if you were to estimate, but they said leave in terms of pi. So that's going to be here. All right, so I'll let you do the others. This, notice, is my diameter, and so you're not going to have to, you can choose to use either one, but for area, for circumference, but area, you have to remember that the diameter is actually 2 radius. So your radius is half of your diameter, so your radius equals 6, your diameter equals 12. So when you do the area formula, you have to use the 6. So I'll let you do the work, pause the video, and pause it, show your work, do your work right here, and then you get circumference is 12 pi, and your area is 36 pi. So if you calculated that out, that's what you should have gotten. You should have work shown there. And then this one, remember this is my radius. You don't need your diameter at all, so don't bother figuring that out. You can use the radius for the circumference and for the area. And if you do that, you get 11 pi for your circumference, and your area is 30 and 25 hundredths times pi. All right, so we defined sector before. I'm going to let you go back to your definitions and define a sector, and then you can also define the arc. Remember the sector, I want you to write in words, but it's just like the piece of pizza, part of your circle, and the arc is just part of the circumference. And so these are the areas for you, formulas, or the formulas for you. We'll give this to you on the test. But the sector area formula, here's the area of a circle, and this theta is in degrees. So if I think about a sector, right here, this has a degree measurement. That's theta. And they'll tell you that if you have to find a sector, area of a sector, they're going to tell you what this theta is. And you have to know the area of a circle, and then it's times this part of the circle, which is going to be the theta divided by 360. So I really think about this, and I draw this little picture to help me remember what I'm doing. The area of a sector equals, and then it's the area of a circle, pi r squared, times part of my circle. So that angle they give you divided by 360 will tell me my part. And so this is just going to tell me what part of the circle it is. And the arc length, remember that was my, where'd my purple go? My sector was my purple. And my arc length was my green. And the arc length, sorry, the arc length, this is my circumference formula right there. So, and so I do this, I put the circumference of an arc here, and so that equals 2 pi r times theta over 360 again. This is your circumference formula, and that's the part of the circle. Same idea. Okay, so I think of this as circumference of the arc. I guess over here, you could, if you want to draw it this way, area of a sector, instead of having it this way, doesn't really matter. This is also a sector, actually. It's just a part of the circle, so it's just a bigger sector. So I'm going to do some examples on the back for you. I know this has been, so far it's only 9 minutes. I'll do a couple examples to help you, and at least see how to do this. So number 1, here's your picture. And so we're going to stick to our colors. I'm going to do my sector is this part here. See, they give you that degree in there. They give you this 110. That's your theta. And then I have to find the arc length, which is also right here. All right, so I'm going to show my work. I'm going to show my work, and then my answers go there. So I need the area, sector, area first. So the area of I'm going to do this sector picture, equals, remember it's area of a circle, pi r squared, times, and then whatever that theta is, all over 360. So area, sector equals pi, my radius, have to find it, right there, is 8 squared, times my theta, that's my theta, that's my radius. My theta is 110 over 360. All right. So then you bust out the calculator. Okay, so we're going to do pi last but not least, very end. So area of my sector equals pi times 8 squared. I know that's 64. And then 110 divided by 360. You don't even have to figure that out. We can just go times 110 and then divide at the very end by 360. So I'm going to go pi. So there's my pi button. Times 64 times 110 equals, divided by 360, and there's my answer. So it's about 61, and we'll go to the nearest hundredth like I've been doing for everything. That's a 3, is my hundredths place, but that's a 5, so I have to round up to 4. So my area of my sector is about equal to, now it's about because I've estimated pi, 61 and 44 hundredths. So area of my sector is about 61 and 44 hundredths. And so now I'm going to do the arc length. So it's going to be my circumference of a sector, or actually it's the arc there, equals, and then that's my 2 pi r, which is my circumference formula, times theta, and then all divided by 360. So plug in my numbers, 2 times pi, my radius, again remember it was 8, times my theta is 110, all divided by 360. So my circumference of that arc, or my arc length, is, bust it up on a calculator, 2 times pi times radius is 8 times, divided by, times 110, ta-da, divided by 360, and there's my arc length, 15 and 36 hundredths. So it's about 15 and 36 hundredths. So the circumference of the arc, which I think is arc length, is about 15 and 36 hundredths. All right. So that's one example. And so I'm going to point out something. These points on this circle had letters, and that's HP. And this says that you want to find HP. And so that is here to here. I'm going to show you this one on 3 at least to get you set up. And this says that it wants to know UGA. That means it wants to go through the point G. So that's from here to here, all the way to here. This amount. But the degree they gave me was this, which is 146. I can't zoom in. I can do this though. Okay, so, but I want this. So remember, a whole circle is 360. So I need to do some math real quick. 360 minus 146. That's going to tell me what this angle is. It's actually called the reflex angle. And so this is 214. So my theta is actually going to be 214 degrees on this one. And so I'm not going to do all the setup for you to save your time, but as you work on this, at the very end, you're going to have it equals pi times your radius is 4, so times 4 squared, which is 6, I'll just put 4 squared, times your theta, which is 214, and then all divided by 360. So when you get that answer, if you do it correctly, you're going to get it's about 14 and 93 hundredths. So I'll let you continue. So your job now with your team and on your own, and be done when I come back, is to do the rest of these. So I did the first one all the way completely for you. The second one's the same way. It says L to O, so you want this part here. And it might help you if you color in what you're looking for. I want that. And this is this part. I know Giselle in my 6th period class is very visual. She loves to color. And so have the colors really help her and a lot of other people. So her papers are always so beautiful. Way better than mine are. Alright. So there's that. And then this one, again, you need to be careful. This is BSH. So if you want BH, that's this part. But that's not what I want. I want BSH. I want this part over here. That's the part that I want you to find. And this length here. So remember, this is 90. It's a right angle. So this has to be your 360 minus 90. And I'll let you figure out what that is. So there's my hint there. Then you're going to continue on. There's more pictures. And this, they're nice and they shaded stuff for you. Uh-oh, they give you the small one, but you want to know what the big one is. Do your reflex. And then this one, and then this one. Read the directions. Do what it asks you to find. These are asking you the degree of the measure of the arc. That's going to be the degree to measure the arc. Area of the circle, circumference, sector area, area length. But all that's going to go together. And then you have this fun challenge. It looks like a lot of fun. I hope you have fun with it. It's called the Pizza Dilemma, and you're talking about sector, area, and arc length, talking about pizza. Smalls, medium, large pizzas, how many pieces you cut it into, and stuff. So you're going to have fun with this with your teams. I can't wait to see what these look like when I come back. So work hard and be good. And I miss you guys, and I will see you very soon. Bye.